All right, hello. As Carolina said, thank you. My name is Sufian, and I'm here to talk about your code base and how you can kind of present a strategy to make broad, sweeping changes across your code base with confidence that you're not going to break anything or cause any problems. And I've stuck these slides, and there's some code that's in these slides. You can get it at this URL, and this will also be at the end of the presentation. And I work at Etsy. Etsy is a marketplace where people around the world can connect to buy or sell or work on together unique goods. And it's more than just a place that you can go on to buy beautiful things like this watercolor of the Budapest skyline. It's also a place for sellers to come together and manage their inventory and deal with shipping and communicate with buyers and even have tax information help. So it's a very, very large company. And in order to make sure that it's working all the time, we have lots of charts and graphs and instrumented code sending beacons back to our servers collecting data. And we have internal tools to help customer service requests and also just general graphs and things like this to make sure that our site is running very well. And we've been around for about 10 years, and we've learned that pretty much in every situation, code grows over time. Features are added, edge cases are fixed, manual processes are automated, and tools are improved. And these two charts show the size of our CSS and JavaScript over 1 year. So last year in May, we had about 330,000 lines of CSS, and today we have about 440,000 lines. And JavaScript went from 700,000 to just under 1 million lines of code. Now, this might sound a little bit daunting, but lots of code is not a bad thing. Every line was written with the intent of helping our customers and making sure that their lives and businesses can be better. And so what we must ask ourselves is how we can help our code. Because our code is here to help our customers, and so we as engineers are here to help our code. And we've got to be realistic about it. You know, rewriting wholesale features is risky and costly. And I think the best way to go about doing this is to constantly make small improvements to our code base over time. And this is true of any code base, whether it's small or large or absolutely massive. And that's the role of the front-end infrastructure team at Etsy. It's our task, our mission, to apply constant pressure to make our code better and to write tools and add to our infrastructure. And ultimately, the people that we're helping out are other engineers, designers, and at the end of the day, the customers who shop and sell on Etsy. And primarily to do this, we build the asset pipeline, which is essentially the transformation system that takes our JavaScript, CSS, HTML, massages them, compresses them, optimizes them, bundles them so that they're assets that can be delivered efficiently over the internet. And so we take these thousands of files, we combine them, and this process is an automated system which will bring these assets to our customers efficiently. And in order to do this, we must understand and transform our code. It's a complex problem, and it has lots of different approaches. But at the end of the day, it's a build system for the web. And in order to have a build system, you must make code that can transform into other forms. And this isn't limited to just bundling assets for delivery, but we can actually transform our code to make it better. But the question is, how do you make broad sweeping changes across thousands of different source files? And how do you do it without causing breakage or having to manually modify every single file? And most recently, we did this to convert our code base from CSS to SCSS. And we've done this several times in the past and found that there is a mental framework to help. And it allows you to kind of remove fear and kind of guide you and allow you to make decisions that can have you cause huge transformations across your code base. And these are the steps. You must identify what it is that you actually want to do. You must automate the transformation so that you essentially have a button that you can press that will cause all these transformations to happen. And then after that's done, you must verify that those changes actually have the correct intent. And then at the end of the day, you must clean up after yourselves and remove any instrumentation that you've added to your code base so that you can actually say, yes, I've done a good job and I can move on to the next thing. So let's go through an example. And because this is a relatively short talk, I'm covering something that we haven't actually done at Etsy, but it uses the same strategies that we've done before, and the code that is at the example here, you could use yourselves if you're so inclined. So let's see how we kind of identify a change that could be made. I was walking through our code base, and I found this hunk of code, which has to do with verifying items in a cart, I believe. And it struck me that this was written by two different people, probably working on two different areas, and they were probably basing their changes off of work that they had done separately. And the question is, why are these different? Why is underscore.bind used and jQuery.proxy used right next to each other? They do the exact same thing. And if I wasn't familiar with one or the other, I might have to look up the documentation, or if I was familiar with both and knew that they did the exact same, I might question my knowledge. And it will slow me down because I have to stop and make sense of things. And this is code friction, something that isn't quite wrong, but could be made much better for the next time someone comes around and needs to make a change in this area. And since we want to help our code, I want to remove this friction. And so all of these, this is three functions, jQuery.proxy, underscore.bind, and the standardized function.prototype.bind. These functions do all the same thing, but they came around at various times. jQuery was written back when we had to support Internet Explorer 5 and other very old browsers. Underscore.js was released the same year as IE8. And at that time, function.prototype.bind wasn't a thing, and so they had to have their own shims for this type of behavior of binding contexts to functions. And since we pass functions all around when we're using callbacks, this is a very handy thing to have. So the question is, why can't we just use ES5, function.prototype.bind today? And this is because we need to have compatibility with all of our customers. We still do have customers that use IE8, and we must support them. And this table shows that, not every browser that is out there supports even features that were released several years ago. But I'm not satisfied with this. I don't want to live in 2009 when IE8 was around. I want to live this year. I want to understand not the history of strange behaviors of old browsers, but worry about the future and pay attention to the present. And so we can add a polyfill. And this is a polyfill from MDN, copied wholesale. Mozilla has a fantastic set of resources for JavaScript, and you can just drop this in your code base, and then any browser that doesn't have function.prototype.bind baked in will have the same behavior. And so if we want to get rid of these two functions and then move on to use function.prototype.bind, we have a relatively straightforward task. We just need to find all of the existing places where they're called in our code base and then just change them over manually. Can't be that bad. We can just open our text editors and see how it goes. But yeah, it's a lot of tedious work. But we're engineers, and we're supposed to automate things, and so there has to be a better way. And so how are we going to automate this? And so if you're thinking about making transformations to text or code or whatever, maybe the first idea that comes to mind is regular expressions. And they're fantastic at matching and pulling out pieces of free-form text. And so if we try this, we can have a first attempt at a regular expression that'll match underscore.bind, and then some stuff, and then a comma, and then some more stuff. And yeah, that works for this simple call to underscore.bind of my function and this. But it doesn't work in the second expression here because the comma is greedy. It'll actually grab that second part, and then you'll have a syntax error. And it turns out that if you need to have something like this, where anything and anything need to be full JavaScript expressions, then you won't be able to do this with regular expressions itself, because JavaScript is not a regular language. And that's a technical term, a regular language. Regular expressions are used to match regular languages. We need to have something better. And it's impossible to do this with regex, no matter how hard you try. And so what we're going to do is introduce abstract syntax trees to our lexicon, which is what's provided when you use an actual JavaScript parser. And this is a simple AST of a function that is the function declaration, whose name is calculate. It takes 3 parameters, x, y, and z, and its body is an if statement that has a test of equality and a sum and a lookup of a member, and it either returns one thing or the other depending on what sides of the if statement it's on. And so if we look back and think about how we're going to automate this transformation, we could use abstract syntax trees. We could parse our JavaScript, transform them, and then generate code from these trees back to its original form. And we can use Esprima. There are many JavaScript libraries to do this, but Esprima is the one that I'm going to use in this talk. And it is quite easy to use. And on its website, there's an interactive parser where you can actually type code in and it can show you the syntax tree as the underlying representation of what that code is. And so after playing with this, we can see that the transformation that we want to make is actually quite simple. We want to take a call to jQuery.proxy or _.bind that takes a function and its context, and just switch that around so that you're calling on the function the property bind with the context. And so how will this look in code? It's surprisingly not that bad. We have Esprima, which we can include as an npm module, and because it's a very popular parser, it has some extra libraries that can be used as utility libraries to help us out with this. ES-traverse is one of them, which helps us traverse and replace pieces of abstract syntax trees. And scodegen is one that generates code from the abstract syntax tree. And so we can simply just read the file, parse it in, and we get an abstract syntax tree out of it. Now, we get some of these extra location, range, tokens, and comment flags added to make sure that we are preserving the contents of our source code, including comments and whitespace. And we have this check that we'll kind of use to identify whether or not we're having a simple call like jQuery.proxy or _.bind. And this might look pretty complicated, but this was pretty much wholesale copied from this interactive parser. And so once we have this, we can use straverse to replace our AST. And if we happen to be matching one of these simple calls that's either to jQuery.proxy or _.bind, we can return the transformed tree and have a thing that we can then pass to the code generator and then write it out to an output file. And that's it. It's only about 100 lines. It's not super bad. And so we could just run this across our code base, commit it, and then deploy and hope for the best. But what could go wrong? Now, we've still got to verify that this actually does the intended thing that we want. So we've made this transformation, and because we've used abstract syntax trees and code generators, we know that it will be syntactically valid. But what we don't know is that these two functions, jQuery.proxy and _.bind, are actually still used. It could be because JavaScript is a very dynamic language. You can do things like this, where you just assign objects to other names, and you can call functions indirectly. That could even be user input that we have no idea where it comes from. So we must ask, how do we find the calls that we've missed? And one thing that you could do is simply replace the definitions of these with errors, and then run your suite of tests. And that's the easy thing to do, because you'll get stack traces, and all of the code that you really care about that's tested will tell you exactly where it is. But we don't have 100% test coverage. I doubt any of you do either. Though we want to, and we love tests, there are always going to be cases that are going to be missed. And so how do we find these failures? How do we find areas that our code just isn't well tested? And if you think about it, our users who are constantly using our code base are testing it much better than any of our tests are themselves. And so if they are our test runners, they could hit edge cases that we wouldn't be able to find manually or automated. And we could actually have them send beacons back to our servers. We could capture a stack trace at the execution point and send an XHR request to our servers. We could write a simple service that would accept these and log these. And then we could instrument the 2 lines of code, jQuery.proxy and _.bind, with this beaconing, sending data back to our servers. And so we kind of have 2 complementary steps. On one hand, we have tests which will cause intentional failure, and that will smoke out most of the issues. But to be very certain, we actually need to monitor production and have production send beacons back to us so that we know how our code is being used. And if we were to deploy this, it would actually be pretty risky as well, because we would have a large transformation, lots of things going on. We might want to actually reduce this risk in a way that makes it much more easy to digest, I guess you can say. And so we could deploy 2 different sets of code, one with our transformations and one without our transformations, and run an experiment between the 2. So we could slowly roll customers from code that we know works to code that might not work. And because we have these instrumented function calls sending beacons back to production, we can actually watch these and make sure that this slow rollout goes smoothly. If we see that there are any issues that are going on, if any of our key metrics drop, we then can turn off the rollout and investigate further. And in order to do this, we'll want to automate this. We'll essentially want a script that will run, transform all of our code, add the instrumentation to these 2 functions, and then we can build and deploy these sets of code. And then once we have that, we can simply wait and watch for these beacons or errors to come up. But what might happen is that errors are not so great. So Etsy has nothing to do with helping to track to.com. Browsers have extensions installed. Users have malware on their system. And sometimes you get errors or other behavior that is completely unrelated to your code. So as you add instrumentation to your code base and watch through these logs, you might want to filter out or at least be aware that a lot of the code that is clearly not yours is still running in your customers' browsers. And so what we have here now is the final step. If we've rolled out completely to our customers, we still have work to do. Our job is almost done. If we've removed those calls to jQuery.proxy and _.bind, we still have 2 sets of code from that experiment that we need to clean up. So we remove one, and we close off the experiment, and we make sure that that is a simpler system than how it was before. And this is all because we want to leave our code base cleaner than we found it. And this is kind of critical when you're working with any code of any size, is when you look at something and you think, I could make this better. You want to walk away feeling, I did make that better. And so we can remove our beacons. And we can even remove the shims, the jQuery.proxy and _.bind function calls provided by these libraries, because they're no longer needed. And effectively, they're only going to add confusion in the future. But if we were to remove them, a developer who could be reading through _'s documentation and realize, oh, I should use this in this situation, they could use it and realize that it doesn't work. So we might want to add a helpful replacement. That's kind of a gentle nudge of, oh, by the way, _.bind is deprecated. You should use function.prototype.bind instead. And in this way, this actually helps us help our code constantly move into a better direction. So it can help our customers, and it can help us at the end of the day. So we can run all of this transformation and commit and clean up after ourselves, and then we're done. And that's how we make changes with confidence. And so as I mentioned before, we've used this strategy a couple of times. We use it for translations. We have strings and files that need to be translated. And so we parse out these files using abstract syntax trees. We beacon back if we ever have an untranslated string that needs to be translated by actual people. And we clean up after ourselves by identifying things that aren't used at all. And we also have moved from CSS to SCSS. We automated our process by cleaning our CSS. Because it was written back 10 years ago, even some of it, there were IE hacks like stars that you would add to the beginning of properties or underscores and other things that would make styling look right in the right browsers. But that's not valid SCSS, and so we needed to get rid of that. We used an abstract syntax tree to verify that the compilation of SCSS to CSS after our cleaning had the same structure as our original CSS code. And then when we were done, we renamed everything over and added a lint rules for SCSS to make sure that our code gets better. So just to kind of wrap up and cover the things we've talked about, JavaScript is a constantly evolving target. And I know earlier today and yesterday, a lot of the examples were using ES6, which is fantastic. But many of us are still serving customers who have old browsers, and we can't jump onto the new technologies as often as we can. But we want to. And so our code must constantly evolve and constantly follow the present of JavaScript. Polyfills are fantastic, and if you don't have polyfills included in your code base, I would highly suggest it. The Financial Times has a great polyfill service, which you can just plug in, and it will give you all of the functions that you might be using either underscore or Lodash or other libraries as shims for. And they're better because if you learn JavaScript, the language, you don't need to learn all of these other libraries which other people use that can be just confusing or get things wrong over time. And parsing and transforming code is easy and powerful. And Esprima is what we talked about today, but Uglify.js 2 is another parser. Acorn is another parser that uses the Mozilla tree. And Shift is a relatively recent parser, and I think that also supports ES6. And you always want to use tests to verify behavior before production. But we also need to be realistic and acknowledge that tests aren't our savior. We won't have 100% test coverage, so we need to plan for this. And we need to monitor production to catch unknown failures. And finally, if we leave our code cleaner than we found it, we'll make sure that we'll put ourselves in a better place tomorrow. So we identify, automate, verify, and clean up. And that's about it. Thank you. Oh, yeah. This is cozy.
Nap time. Okay. Oh, there are a bunch of questions, actually. First one, how do you do the soft deploy in practice?
So we have configuration flags that exist. So we use PHP on the back end for most of our services at Etsy. And we have a set of configuration files that are essentially checks that you can say, if you are in this experiment, you can have this behavior. And if you're not in this experiment, you can not have this behavior. And so you can have a number between like 0 and 100 for a rollout. And for this particular example, you would want to serve the URLs of set A or set B, depending on where you are in this experiment. And we bucket by session ID. And you want to make sure you don't use a customer ID if you have a login ID for your customers, because you'll bucket all of the logged out users into the same one. And if you have lots of logged out users, it'll be very disproportionate.
Are there any existing generic JavaScript refactoring tools, or you have to write always a specific transformation?
Yeah, this is something that there are many tools out there for. I think there's one called S-Transform. Facebook has PFFF and S-Patch, and these work across many different languages. The reason why I stepped through this is because I think that understanding how to parse and manipulate code is actually kind of enlightening, and it allows you to think about code as data, which is a very powerful concept.
Would you write tests for the transforms on the code during the process?
Who tests the tests? That's a good question. I probably wouldn't, to be honest. And I say that because it's either going to spectacularly fail or it's going to work. The chance that it will like subtly break would be pretty low. And because we're monitoring production, we would have a higher confidence about that. But you could write a test if you wanted.
So this one is pretty interesting. I'm missing the from inline.js to AMD part of the presentation. Could you briefly go over it?
Wow, that's like another talk.
We have time, I guess.
Yeah,
well, we have a little bit of time.
Oh, did I go short? So I think the question was essentially, how does Browserify work? And
how does Browserify work? I think we have someone in the audience who can actually just say that.
Yeah, so you could use this technique to transform JavaScript modules that are written in AMD style to common JS style, or go the other way around. You could do this to bundle your code into individual bundles, so you kind of bring in all of your dependencies into a single asset. You could do all sorts of things. I hope that answered the question.
How do you monitor client-side errors, external service, or something that you've built?
Yeah, so if you have a on-error handler on window, you can get some good information, and it varies on browsers. And also the error messages that you get are also localized. So if you have your browser set to be Italian, for instance, and you have an error that is something like a null pointer exception, it will have that sent back to you in Italian, which is not very useful. But there are third-party services, there are tons of them, that you can use to drop in a library, and it kind of attaches to all of the exit points, so you get better stack traces in browsers that don't necessarily have them. And essentially just in that error handler, you send as much information as you can to your servers, and then you can search through them. We use the ELK stack, Elasticsearch, to go search through our logs and find out how errors are popping up.
So I'm not sure if this question is going to be clear. Maybe it will be. How do you rule out partially that big of a change?
Sorry?
The question says, how do you rule out partially that big change? And I'm not sure what that means.
I'm not sure what that means either.
Is that person in the audience somewhere? Or is it from the string? Because I could not tell. Well, if someone who asked that question wants to clarify, that would be great. If they don't, we're taking questions from the audience. Yes, no? I see no hands. There is a hand. Can we get a mic over there?
Thanks for the talk. It was very well explained. You mentioned that you are using Esprima to transformations to ASTs. Mm-hmm. My question would be, did you run into any issues when you transform this probably really large code base, made those changes that were specific to just the bindings and proxies, and once you generate it back into the code, I'm not sure if you used SCodeGen or something else, did the whole commit message, or the whole commit became too bloated with some minor changes that weren't really related to the proxies or binding, maybe different formatting of indentation or something like that?
Yeah, the formatting and indentation, if you have lint rules already applied to your code base, that makes it a lot easier because you can configure SCodeGen to use those same rules. But if you have a code base that doesn't have a standardized style, then the formatting will change. And what you could do is use Git or even diff to kind of remove the white space changes themselves, and that will kind of minimize the number of formatting changes that you have there. But that's probably the biggest thing that could come up with this, is that by parsing and generating your code, you lose a little bit of information. We do retain all of the comments, which was what those extra options added were, and even the comment structure, if it's all aligned, for instance. But we do lose a little bit of formatting.
Thanks.
Oh, there's another question to the left.
Hello. Well, I have two questions actually. And first one is, what's the lovely font, the typeface that you use for your presentation?
Oh, that's Guardian.
Guardian.
It's the typeface we use for Etsy's logo.
Cool. The other one is, how do you deal with code legacy maintenance of CSS across the whole site? How do you deal with duplicated code or unused code, or how do you refactor that? I mean, there are no quick ways to do so, but you must apply some techniques anyway.
Yeah, CSS is, let's just say, even more dynamic than JavaScript. It is extremely hard to remove because you don't know where it's being used. We've toyed around with the idea and used this in small cases. We haven't really built a large project around this yet, but if you add a background image to CSS elements that's like a transparent 1 pixel beacon, and then use that to send to your servers, and you can search your access logs for these, you can identify whether or not that selector is actually being used. And you could, across that code base, kind of like decorate your CSS with these to kind of identify what is being used and what isn't being used, which is a way of eliminating so much CSS. That's something that we really are excited about doing, but we haven't yet done. So yeah.
So it's like a Google tracker for CSS.
Yeah.
Cool. Yeah, thanks a lot.
Mm-hmm.
There's another question over there. Just chiming in on the CSS topic. There are tools like Helium CSS that, I don't know if you heard about it. It like searches for selectors that are used per page and then remove the CSS that's unused. But like it takes a certain amount of maintenance to actually be taking that out. Like it's not one of the CLI tools that you just run it, and it just does it on its own, and like you can just sit and relax. Like it doesn't work that way, so it takes a little bit of work. It's a challenging topic.
Yeah,
definitely.
it's a really hard problem.
Hello. Have you ever used ASTs in tests? Like sometimes like code changes that can't be done automatically, like non-localized strings, for example.
Oh, yeah.
So have you used ASTs to detect those in tests or something?
Yeah, what you could do is, so there are some tools that use ASTs to identify scope problems or variables that are undeclared or unused. And in the talk yesterday, they mentioned ESLint. The newer version, you can actually give it like custom rules that can identify your syntax trees, and you can add these to your lint that you have on your code base to kind of enforce the good patterns that you want or remove the bad ones.
Well, I can't see anyone raising their hands, so I guess we're done. Thank you.
Okay, cool, thank you.